Hi everybody, today's lesson is going to be about the equation that we will see when there is a proportional relationship. So the equation itself is going to be y equals k times x or kx equals y. You might be wondering, what do you mean when you say k? It is the constant of proportionality. Constant of proportionality, and you saw this with the table. It was that number that you took that we multiplied one of the columns by the number to get the second column. It was the same number every time, so that's why it's called the constant of proportionality. I can't talk and write at the same time. We also call it the unit rate. The unit rate and the constant of proportionality are the same exact thing. We know that the unit rate is y divided by x. This is what we've been talking about. Why am I giving you a new name for it? I don't know, but I am. You can call it unit rate or you can call it constant of proportionality. When you see it in an equation, we're representing it by the letter k. Just remember that x is going to be the input. So if I put in 4 hours, time would be the input there. The output might be money. I get paid $40 or something like that. You'll see different relationships, but that's what we're talking about. The equation will always look like y equals a number or a constant times x. So let's look at these 3 equations right here. The question is, does the equation represent a proportional relationship? And just to remind you, we're looking for the pattern y equals a number or k times x. So let's start here. Y equals 3x. Yes, this is a proportional relationship. K in this case is equal to 3. The second one, y equals 1/2 x. Does this represent a proportional relationship? Yes. K is equal to 1/2. Last but not least, does this represent a proportional relationship? No, it does not. Here's why. This -1, that is not in the pattern here. So we're going to say no, it isn't in the form y equals kx. There's that extra -1 there. So the big question is, how and why are we talking about this? How are we going to use this? Why is this going to help us? Let's look at this table right here. Here's a relationship. The relationship is between gallons of gas and miles. So my gallons of gas, that's my input. That's what I'm putting in. What I'm getting out is my car going a certain number of miles. So this is the output. This is the input. The question is, how do we use an equation to represent this relationship? Same thing we did with the table before, right? Let's find the unit rate, or we're now calling it, another name for it is the constant of proportionality. So let's start here. It's still y divided by x. This is the same thing that we've been talking about. I'm going to take 204 and I'm going to divide it by 6. In my calculator, that's going to give me 34. I could do this again with this pair, y divided by x, 272 divided by 8. That's going to give me 34. What does this mean? This means my unit rate, or my constant of proportionality, k, is equal to 34. Now, if we were to create an equation, the equation would be y equals, remember, y equals kx. K in this case is 34, so y equals 34 times x. What are we saying? We're saying that we can take the gallons of gas, multiply that by 34, and that's going to give us the miles that we can go. So where would we use this? Well, if we had the question, how many miles can you drive with 12 gallons of gas? Now that we have this equation, we don't need to create a table. We don't need to plot a graph. We can use the equation. We know if we're talking about how many miles, that's y. So what we can do is take this equation, y is going to equal, we know it's 34, and then we can plug in 12 gallons here to get our answer. Now we'll just plug into our calculator 34 times 12, and that's going to give, I should have said miles per gallon. I should have put my units, shame on me. So 34 times 12 gives me 408 miles. So that's how you would use this equation that we have.